Exercise 2.2, question number 3. Verify whether the following are zeros of the polynomial indicated against them. So, first problem, that is px is equal to 3x plus 1, where x is equal to minus 1 by 3. So, if x is equal to minus 1 by 3 is a zero of a given polynomial, that is px is equal to 3x plus 1, then p minus 1 by 3 must be equal to 0. So let's check it. P minus 1 by 3 P minus 1 by 3 is equal to 3 minus 1 by 3 plus 1 equal to minus 1 plus 1 equal to 0. So here we can see that x is equal to minus 1 by 3 is a zero of the given polynomial. So the answer is yes. Second, px is equal to 5x minus pi. X is equal to 4 by 5. So if x is equal to 4 by 5 is a zero of a given polynomial 5x minus pi, then p 4 by 5 must be equal to 0. So putting x is equal to 4 by 5 in a given polynomial, we'll get p 4 by 5 is equal to 5 into 4 by 5 minus pi. This is equal to 4 minus pi. So here we can see that by putting x is equal to 4 by 5, we are not getting answer as 0. So x is equal to 4 by 5 is not a zero of the given polynomial. So answer is no. Third, px is equal to x square minus 1, x is equal to 1 minus 1. So if x is equal to 1 and minus 1 are zeros of polynomial x square minus 1, then p1 and p minus 1 should be equal to 0. So let's put x is equal to 1 first. P1 is equal to 1 to the power 2 minus 1 is equal to 0. P minus 1 is equal to minus 1 to the power 2 minus 1 is equal to 1 minus 1 is equal to 0. So here we can see that by putting x is equal to 1 and minus 1, we are getting answer 0. So x is equal to 1 and x is equal to minus 1 are zeros of given polynomial. So answer is yes. Fourth, px is equal to x plus 1 into x minus 2. X is equal to minus 1 and 2. Again in this case also, if x is equal to minus 1 and 2 is a zero of a given polynomial, that is x plus 1 into x minus 2, then p minus 1 and p2 must be equal to 0. So first check with p minus 1. P minus 1 is equal to minus 1 plus 1 into minus 1 minus 2. is equal to 0 into minus 3 is equal to 0. P2 2 plus 1 2 minus 2 3 into 0 is equal to 0. So here we can see that we are getting P minus 1 is equal to 0 and P2 also as 0. So we can say that x is equal to minus 1 and 2 are 0 of the given polynomial. So the answer is yes. Next, fifth, px is equal to x square, x is equal to 0. So again we need to check if x is equal to 0 is a 0 of a given polynomial x square. So putting x is equal to 0, p0 is equal to 0 to the power 2 is equal to 0. So therefore we can say that x is equal to 0 is a 0 of given polynomial. So the answer is yes. Next is part 6th, that is px is equal to lx plus m, x is equal to minus m by l. So again we need to check if x is equal to minus m by l is a 0 of a given polynomial, that is lx plus m. So putting x is equal to minus l by m, l into minus m by l plus m, this is equal to minus m plus m is equal to 0. So again we can say that x is equal to minus m by l is a 0 of the given polynomial. So the answer is yes. Part 7th, that is px is equal to 3x square minus 1, x is equal to minus 1 upon root 3 and 2 upon root 3. Now let's check if x is equal to minus 1 by root 3 and 2 by root 3 is a 0 of the given polynomial, that is 3x square minus 1. So p minus 1 root 3 is equal to 3 into minus 1 upon root 3 whole to the power 2 minus 1. This is equal to 3 into 1 by 3 minus 1 minus 1 minus 1 is equal to 0. Now p 2 upon root 3, 3 into 2 upon root 3 whole to the power 2 minus 1, this is equal to 3 into 4 by 3 minus 1, 4 minus 1 is equal to 3. So here we can say that x is equal to minus 1 by root 3 is a 0 of a given polynomial. So the answer is yes. But x is equal to 2 by root 3 is not a 0 of the given polynomial. So the answer is no. Last part, px Px is equal to 2x plus 1, x is equal to 1 by 2. So let's check if x is equal to minus 1 by 2 is a 0 of a polynomial 2x plus 1. So putting x is equal to 1 by 2, we will get p1 by 2 is equal to 2 into 1 by 2 plus 1 equal to 1 plus 1, which is equal to 2. So here we can see that p1 by 2 is not equal to 0. So x is equal to 1 by 2 is not a 0 of the given polynomial. So answer is